again, tools along the way, make the tool do the job, run the tool the right way, and you're going to be fine. These machines will do it. You don't need to be that 20-year veteran to do paint correction anymore. Not at all.
All right, who can tell me what is paint correction?
Remove the surface defects from the vehicle.
Really, and it's even on the more simple side, just that first couple words, right? You're removing surface, whatever. So, first let's talk about how to prep the car. The car, you sold the job, it's coming in your shop. What do you have to do? You gotta wash it and clean it. That means wash it and clean it in its entirety. Do the interior, open the door jams, hood jam, trunk jam, the wheels, the barrels of the wheels. Get all the cleaning done at one time. You don't want to clean the car, bring it in here, start a process, and then in order to move forward through the rest of the process, have to double back and go and clean something. Plus, while you're cleaning, you should be set up for success, have all your tools there ready to go, and you can clean it at that point in time. So, you wash and clean, then you have to clay. What does clay do? What? I always get mixed answers, but the only thing that clay does is to remove embedded contaminants from the paint surface. So whenever we compound, we clean it, whatever, there's still microscopic holes in the clear coat. So tree sap, tar, bird crap, there's other things that can bond and stick to the clear coat, and it doesn't come off through simply cleaning it. So the clay is simply removing embedded contaminants, very, very similar to like the blackhead pore strips you put on your nose. Put it on there, leave it, you pull it off, and it strips out from within. So that's clay. Iron X. Iron and metallic or ferrous elements rest in the pores of the clear coat as well. So whenever industrial equipment is running, it burns that type of material into the environment. It rains, it brings that back down. It gets on the car, it goes into the pores. Brake dust is metallic powder. There's other naturally occurring things in the environment that add iron, metal, and ferrous to the random surfaces. You have to get that out in order to get a proper bond of the coating. So you use Iron X or iron and fallout remover. We use Micron release usually, but that is going to remove metallic and iron things from the pores of the clear coat. Wax and grease remover. So after I've cleaned the car, clayed the car, iron and fallout remover, now I want to do a wax and grease remover. And the reason I'm going to is because if it has a previous form of protection on there, I need to remove it before I start my paint correction, because if I don't, then I'm going to pull that protection into my pad, which is going to decrease my efficiency and slow down the process of paint correction. So wax and grease remover strips any wax, polymers, sealants, anything that may be left on the surface prior to beginning the paint correction. It's also, if you had it waxed and you try to tape it, the wax doesn't stick, right? So whenever I wax and grease remove it, now my tape sticks. So if I'm taping the car, why am I taping it? I'm taping it for two reasons. So I don't stain any of the plastic or more porous surfaces of the vehicle white, where I have to do some, I don't want to go back and have to fix that. Or the machine's rotation in and of itself can cause abrasion on plastic and mess it up. So we're simply protecting the process. We're making sure that we don't mess the car up through the correction process. So that's our prep. Whenever I start my paint correction, there's only two processes. I hate the word step because we're programmed to think 1 step, 2 step, 3 step, 76 step, doesn't matter. But there's two processes. One is remove the defects. 2 is remove the evidence of removing the defects, which is called polishing. So a paint defect is an uneven surface in the clear coat. So you have metal, you have paint, and then you have clear coat, which protects your paint through improper wash techniques and a variety of other things. You get uneven clear coat surface. So in order to take that away, make the surface swirl free again, like he said, you have to remove clear coat. So whenever you remove clear coat, it's just abrasion, time under friction. So we're just basically taking, this is our clear coat, and we start wearing it down. take some off, take some off, take some off. Now I'm down to nice, even, level clear coat. Anybody tell me what orange pill is? Orange pill is like that texture in the paint. So when you look at it, when you look in a mirror, you get a perfect reflection because the mirror is perfectly flat. When you look in the paint, it looks like ripple because they spray it on as a liquid. As it cures, it's like moving down, it's thick, but it causes a little bit of ripple. So paint correction typically will not get that out. It could potentially minimize it, but it's typically not going to get it out. If you want to get it out, you need to wet sand, right? So wet sanding is just a more aggressive form of abrasion. So that we're using our tools for abrasion. We're not going to get the orange pill out without sanding. Typically, we don't sand. It's definitely not something we teach in this class. So we get to our tools. So basically, our different tools. We have our machine. We have our machine speed. We have the amount of pressure that we physically apply to the process. We have the tempo, which is how fast I'm moving my machine. And then I have the pad, the buffing liquid, and my residue control. If this was a math equation and you added all these things up, it would equal your technique. So you can also manipulate your technique. Imagine this is like a scale, right? You step on the scale to weigh yourself and you move it. So you can take any one of these tools. There's a maximum level of aggression and a minimum level of aggression. So I can take any one of these tools, my machine, max level aggression, rotary. Why? Direct drive keeps going one direction all the time as fast as I want it to. Next one would be a forced rotation dual action machine. Means it oscillates and spins, but it's forced. It's going to keep going no matter what. Those are usually an 8mm throw on those machines. And then you have a DA. So a DA is a dual action. It rotates and it oscillates, but it has a safety mechanism built in to where if the machine senses that you're in a compromising position, then it pulls the rotation out of the function as a safety. So it's basically trying to prevent you from causing an error. So most aggressive, less aggressive, right? You have your machine speed. Typically with the Mark II and Mark III, I never run it consistently over 4 to 4.5. Now, if I'm running the lower side of a door where the two curves meet, I call it a valley. If I'm running the valley and I'm trying to get my machine down in there, the safety is going to engage, so I can overpower the safety with machine speed and torque. So I'm moving the level of aggression back up on that scale. Pressure. Typically, whenever we're going to be working today, I just want you to use the pressure of the machine. Like, just find a way to balance the machine on the panel. Do not physically apply pressure. Some of you are very experienced. You're more than welcome to apply pressure. If you haven't worked with these machines very often, don't apply pressure. Pressure is only a value-added part or a value-added tool if you know how to run that tool. If you don't know how to run the tool, then pressure is going to make the machine think that you're in a compromising position and most likely going to pull the rotation out of it. So that's why you find that balance point. Once you're able to run it under full rotation, balanced on the surface at all times, then you're ready to start applying pressure. So no pressure, lots of pressure. Tempo. Whenever I'm moving very slow, means I'm over here on the maximum level of aggression. If my tempo is fast, it means I'm not going to remove as much clear coat in that panel because I'm moving over it very quickly. So tempo, fast, is less aggressive, slow, more aggressive. Pad. There's a couple different types of pads. There's wool pads, microfiber pads, and foam pads. You can have a defect removal pad or a polishing pad of every kind. So there's wool pads that are cutting wool pads and polishing wool pads. There's cutting and polishing microfiber, and the same with foam. And then you have another characteristic of foam, which is an open cell foam and a closed cell foam. Open cell foam is better for traditional clear coats. Closed cell foam is better for fiberglass, gel coat, single stage paint, aviation, because it's not going to allow you to load as much material that you're removing. It's not going to load as much with your bumping liquids, so it's going to be a more effective tool on those surfaces. So we can take those pads, color doesn't matter, material doesn't matter, but the simple truth is there's more aggressive and less aggressive forms of every type of pad. So then we have our liquid. Same thing, pretty self-explanatory. Super abrasive, not very abrasive. And then you have an additional characteristic of compound. It can be a standalone, hard cut, 1,000 grit compound. Means it has a cycle, right? You cycle it. You put it on as a liquid, you introduce friction, and friction runs it through a cycle to where it's no longer usable anymore. So if you have 1,000 grit, a heavy cut compound, from the time it starts its cycle to the time it finishes, it cuts at the same aggression. Or you have a diminishing abrasive compound, which is like this, the FG400 or Micron 1500. What that means, you have a big abrasives. As you begin to cycle them, they shrink, so it becomes more like a polish. So what that does, it allows you to remove deep defects, but also ushers you into the polishing step without having to add other pads and liquids in order to remove the evidence of the previous step. So the more aggressive you are, the harder it is to work your way back to perfect. The deeper the scratches, if you go more aggressive, then it's harder to refine it back the other direction. So you can use things in your technique. What I usually do when I'm both compounding and polishing, let's just say for standard unit of measure, we're gonna make 4 overlapping passes. So typically whenever you make a pass, you go left, and then you drop down 50%. If you're using a 6-inch pad, drop down 3 inches, then you come back the other way. Then you drop down, come back the other way for the size of your section. Then you change your path of direction, vertical, same thing, overlapping passes. So let's say we're gonna make 4 passes. We're gonna go left to right, up and down, left to right, up and down. It shouldn't take you longer than 2 minutes. If it's longer than 2 minutes, you've most likely evaporated and used this liquid to its full potential, and it's no longer functioning for you in an effective way. So if you're running it more than 2 minutes, you're probably overusing the liquid capability. So I was saying technique. Say we used to do 2 passes. So I may go more speed, more pressure, slower tempo. So that's moving me higher on the aggression level. I do that horizontal and vertical. Then I may pull out pressure, slightly increase my tempo, and back the machine off. So I'm becoming less aggressive. But what I'm doing, I'm using the same tool, but I'm altering my technique in order to get me from let's get the scratches out for 2 passes to let me get to the middle of the road so that I can move to polish. Same thing with the polish. Whenever I get my polishing pad and liquid, the first 2 passes, slightly slower, slightly more pressure, more machine speed so that I can knock down the micromarring. Then I want to finish it out to perfection. So I'm going to back the machine speed out, pull my pressure out, increase my tempo. So on these dual action machines, they oscillate. In order to remove deep defects, it's better to go slow. In this process, slower is faster, right? Because slower puts us more aggressive, so we're going to get better results of removing defects. If you're hem-hawing around, moving, you're not going to get them out. It's going to take too long. So, forgot where I was at. Anyway. So, what was that? Yeah, so just, I was saying the machines, the micromarring. So by technique, like I'm moving slow, more pressure, more speed, aggressive pad and liquid. The machine's sitting there oscillating like this. So what it's doing is it's causing little bitty micro scratches just from the process. So on this black paint, we'll show you, we can get all the scratches out, but then the surface is still left like milky, hazy, kind of white. Or if you were seeing big swirls before, now whenever you look, the paint looks clear, but if you look real close, you're seeing tiny little bitty swirls. So all that is the evidence of the first process. you're causing little micro scratches. And because you're moving slow, those micro scratches are paired really tightly. So whenever I move to polish to remove that, and I'm moving to the less aggressive side of the spectrum, I'm going less machine speed, faster tempo. So if you're having trouble finishing the paint, back the machine speed out, pull your pressure out, increase your tempo. So what that's doing, instead of stroking like this, now it's stroking less because the machine's turned down. Instead of like this, it's like this, so less strokes. My pressure's out and my tempo's higher, so I'm spreading that stroke out over a larger area, which in turn tricks your eye and you can't see the defects anymore. So that's how you get paint perfect, just kind of that process of aggression. So when you go to the car, you're gonna examine it. You're gonna take your light. This is a color match light. It's designed for the body shop industry in order to match color on panels whenever they repaint cars. In order to examine the paint, the light source that you're trying to look at needs to be 45-degree angle from where you are. So if I'm trying to look at the paint right here, I need this to be 45 degrees out. So I look at this light source like that, or like that, or it could be above my head, or it could be below my head. Any one of these places is 45 degrees, right? So if I'm looking at defects to examine the paint, if I'm trying to remove coating, I need to be 45 degrees from my light source. So what I like to say, one of the best things you can do whenever you're working, I got a light on my right side, I got a light on my left side. I like to use shop lights, like 48-inch shop lights, so I have a full spectrum of light whenever I'm sitting here. Now when I look at my paint, I got a light source, I got a light source. I don't have to move anything, I don't have to get anything, and I can see what I'm doing. So to examining it, you want your light at a 45-degree angle. The color match light, what makes it different from like this light is probably a 95 CRI. CRI is a unit of measure. The color return index measures how close a light re-emulates the sun. This is 95%, this is like 97. Very small margin makes a big difference in your ability to see what's going on the surface. So that's your light source. Now we have our test section. So whenever you've assessed the paint, now you're going in to solve a problem, right? Truly problem and solutions. Over here we have heavy defects, that's the problem. Our solution is to make it perfect. So I have a section this size. I have my technique. I have my tools. I know how to manipulate those tools to be more or less aggressive based on, am I getting the defects out? Am I not getting them out? So I want to, in theory, get all the defects out by running that section one time. I don't want to have to pick a section like this and go over it 3 times. So do you think anybody have a way that I can take that section with the same defects? How can I get all the defects out in one pass?
Find out which chemical and which pad operates effectively on it.
Right.
Don't have no light on.
We're assessing the tool, right? Go ahead.
It's also if it's hard or soft.
Yeah. Whether the paint is hard or soft is just going to make it easier or harder, basically. So you're just moving your aggression level. But what I want to focus on is, even if you're running a section this size, you run it one time. All the defects aren't out. What do I do for section 2?
Change it.
I make it half the size. By making it half the size, I'm giving my tool twice the chance to do the job that it's there to do, right? So instead of working that big section and running it, I'm gonna shrink my section, run it the same way one time, and get all the defects out.
So what he was saying is, if we're working on a section that
I
big,
have it on the other side. I'm gonna
Oh.
go there.
oh shit,
I'll take the marker. Give me that. Go stare in the back.
I like the backside.
I know. So here we are. Yeah.
You mentioned about working a section like this, and you still have defects, right? And you want to make a correction, you go to a smaller size, right? Seems to me, wouldn't you want to start with a smaller size first and then expand it?
Well, the very first time you learn it, you have no unit of measure. So pick a size if it works. If it doesn't, make it smaller. Right? We're assessing the unit of measure. We're establishing our process. So the first time I run it, no matter what size section it is, I'm rolling the dice guessing. Come on, baby, let's get it. That didn't work. Let me adjust. Redo it. Second section works. Now I have my process. I repeat that process until that step is done. Once that step is done, and I have only micro marring, no scratches, assuming they wanted a 90% correction, because you're only delivering to the expectation in which you sold the job. So, examine, test sections, develop your process, execute the process, and something to always be aware of is from the belt line up is going to be where you want the car to be, usually the best, because that's where all your sun light sources are going to hit, 40 or from the belt line up. Belt line down, you have to think, if I'm trying to see scratches in the bottom of the door, it means it's got to be 7:30 at night, the sun's about to go down, and I'm looking at my car like this. Oh, there's one. So the lower parts of the car, you're not going to see the defects as easily because there's never the light source to identify those defects. So spend your time on the top half. If you're going to short time on the bottom half of the car. So, anybody know what a RID is? R-I-D.
Random, isolated, deep scratch.
Yeah, RIDs.
Rig.
RIDs, random isolated deep scratches. This is our clear coat. This deep scratch here is a RID. It's a random isolated deep scratch. It may not be the best idea to get that out all the time for a couple reasons. One, I'm taking more risk at messing up that car because I'm taking a lot of material off. If I'm taking a lot of material off, I really need to know what I'm doing, or I need to have a tool to evaluate that. So you can get a Micron meter. If you have a Micron meter, it can measure the depth of the paint. You can take readings, assess the average. So if I was to take a reading on the hood and it reads 7.5 microns, and I'm like, okay, what's that mean? So then I open up the door, I take a reading in the door jamb, 3.5 microns. They skimp paint on the inside of the doors as a manufacturer, because that's where it needs to be the thinnest. So out on the hood, 7.5 microns. I know I have about 3.5 to 4 microns of clear coat to work with. If I get this scratch out, how much clear coat is still left above the paint surface? Very, very little, right? So it's the risk versus the reward. I'm sacrificing the structural integrity of the clear coat and compromising its job. Its job is to protect my paint. If I cut its legs out from under it, it's only got half as much ability to do its job. So it's not always best to get every scratch out. Yes, sir.
Also, too, on OEM paints, the UV, isn't the UV?
Yeah, clear coat is much more UV resistant than a coating is. And so if you take it all off, much higher chance of clear coat failure through oxidation.
Because the UV is also built in, but there's only a certain percentage that's usually on the top of the OEM paint. So the more you take off, then the UV is going.
Right. You're going to have less protection. You're sacrificing the structural integrity of the clear coat to do its job, which is protect the paint.
And that's one of the things that I do, one of the selling points when I'm fixing somebody's paint or something. It's like, I don't want to try to take off. So, as far as what's going to be left in the paint, I try to explain to them that this is what I'm doing because, the structural thing of the paint, I'm taking off too much. But then, when you're coating it, you're also putting an extra, the sacrificial layer. But as far as taking off all of this and taking all the scratches out,
So, recommend we color sand that scratch out.
I recommend you make the choice. My prescription would be assess the scratch,
Assess the scratch.
make the client aware of the risk,
Right.
allow them to choose.
Right.
That way, if they choose, I want it all the way out, you tell them, well, if I burn the paint, getting it all the way out, it's your choice.
Right.
I'll go there, but,
Feet up front,
the accident's on you.
Yeah.
Otherwise, whenever you get it back, you already know that's going to be there. no miscommunication, right? So
On
when
that
is it?
issue, do you have them sign off on that? You say it's okay to go?
No, I've never had anybody try to call me on
Right.
that.
We also know if we're messing with a new car, and let's say we wet sand it up, we do make it look perfect, we drop the integrity of that area down to from we're at 100% technically, maybe we're down to 20%, and you just bought this car. So again, just tell your clients, if your professionalism, it'll rub off, and they'll be like,
Your
oh, you know what?
professional opinion.
Your professional opinions, it'll rub off. There's no sandpaper in my shop. Have we ever got turned down for a job that we don't sand? No. Because we, assess the situation, tell them what we think, and they're like, I'm like, hey, I can get that scratch to where you need to look at it at an angle and do all that. Is that fine with you? Because then that protects the integrity of your paint like Travis was talking about. Or is it a show car thing where it's got to
Go at it like this. Restore, remove, repair. What am I doing? Am I going to restore it? Am I going to remove it? Or are you really in more of a repair situation, right? So just assess the risk, communicate the risk, allow them to choose, develop the expectation, and execute the process. So let's say why should I get a paint job perfect? If I have like a 1960 Corvette, fully restored, brand new paint job, it's freaking immaculate, and it's gonna sit in my garage until I take it to a car show 3 times a year. That may be a car worth getting absolutely perfect. If you drive a car every day, I can get it perfect about 100% of the time. Whenever your client washes the car, it's gonna be way worse than I just spent 5-6 extra hours getting all these lines out, and improper wash techniques can be reintroduced the very first time. So evaluate your time, don't waste it. Let's see, residue control. So if you think about optimum performance, right? Or the maximum performance of this tool. This tool works the very best right when I pull it out of the package. From the time I start using it, the result, the efficiency, the optimum performance just starts to depreciate. So if I don't keep that clean, it depreciates much faster. So if I take it out of the pad, I put it on the machine, and say every pass or every other pass, I use air to blow and discharge all the material that's being clogged in the pad, then that's going to be a much more effective tool for me throughout my process. So use an air compressor to clean your pad. If you don't have an air compressor, you can use a brush or a towel, but it's less effective at cleaning the pad. Oh, that died.
Pad tool, Tornador.
So if you don't have air, it means you're cleaning it with a brush or a towel. It means you probably need 6 or 7 pads to compound this car. If I have air and I can clean my compound pad out, it may take me 2. So you have to assess the environment, develop your process, and repeat it, execute it in the most efficient way possible, right? So, ergonomics. We'll kind of talk about this once I show you a test section, but you're trying to keep the machine flat on the panel. If you hold it like this is exhausting. I can tell you right now, if you try to hold this machine out here, you can't do it all day, right? So if you're sitting behind this thing for 8 hours, there's a right and a wrong way to hold it. So if I'm polishing the car, I'm usually anchored to my body. I'm embracing this thing like a gorgeous little baby, balancing it, setting it as flat as I can on the surface. A lot of times I move my hips. I just lean in. I'm going left, now I'm going right. But I have full control of this machine. It's balanced. I'm not carrying the weight, so I'm effectively using it. Same thing up and down. Or you can use a pivot point. So I'm anchored in, sitting on my heels. My elbows are resting, and I can pivot this machine up and down with one hand very easily, because I don't even have to support the weight. Sitting on the car now, I can drive it with one hand, back and forth. You should be able to just operate it with 2 fingers at all times. If you're not, then find the place to balance it, right? So ergonomics. Down here, get braced up, use your hips. But you want to find a way to be able to control this machine easily. On the hood, it's not flat. Looks flat, it's not flat. Starts here, bends down like this. So when you're standing out here and you're going up the hood, common misconception is to pitch the machine down. Machines like this, you're driving up the hill, down the hill. Same thing with the side of the door. So, this is my amazing drawing of a door. So when we look at this door from the side, it looks like this. It's hard to keep this flat right here, right? So you're constantly manipulating the way the machine sits on the surface so that I can keep it as flat as possible. These are mountain peaks, these are valleys. This is the top of the door right here. This is a sharp peak. This is the door. It's a very subtle curve. This is a subtle peak. This is the bottom of the door. Subtle valley. This is the rocker panel. Very sharp valley. So, from every peak, from every valley, is like a mountain pass road. So, there's a 50-50 point. Point. So I want to work this side, then I want to work that side. Out here, it's less important, but you just have to know as that panel shifts, you have to move your machine. But down here in the valley, like I said, whenever you're coming down here, down here, down here, even though it's not a sharp turn, you get into that curve and it starts making the machine uneven, stop spinning. So the better way is to, from right here, you find that line, the very bottom of the valley, and you work all the way this way. Then you drop down, make your U-turn, and then work this side of the valley. So you basically, if you have a curve like this, I'm working this as one side, I'm working this as one side. Same thing with the peak. I work this side, then I work this side, right? Machine's spinning this way, clockwise. You want to roll off your edges so that if I have an edge like this, my machine's spinning this way. So as the machine comes around, I don't want it biting that top edge that's coming back around on. So what that means is I give very, very slight adjustment of pressure, just enough to, just enough to the 9 o'clock side of this clock face. 12, 3, 6, 9. Very slight 9 o'clock pressure, which picks up my 2 o'clock contact point and stops it from coming back around on the edge. The edge is thin. So by technique, you're giving yourself a better chance not to burn edges. So you want to roll off edges. You're not picking the machine up. It's literally, just enough to make a difference. So whenever I pick my section, let's say, we'll go back. Say I did half of the top of the door, and I still have ribs. That means the second half gets broken into quarters. That way I have a more effective chance to remove the defects in a one-pass situation. I always do my edges first. If you've done paint correction, what is the most common place to have scratches left over? The edge or the valley, right? So let's cut the bullshit and go straight to the problem. Let's do the edges first. So as I do this, I'm gonna start right here, and I'm gonna walk down this way, and I'm gonna hit this whole edge. I may make 2 passes intentionally running that edge. Like I run the edge, and I really wouldn't want to come back this way because I'm kind of like fighting against the way the machine wants to go. So I may drop down away, make my U-turn, come back up, pressure and position in, balance, it's free spinning, and I walk it down that edge again. So I do my edge, I do my edge, I do my edge, I do my edge, What do you think coincidentally happens to the scratches in the middle? They go away because you have a 6-inch pad. When you run this edge and you run this edge, you overlap the middle. So who cares what's going on in the middle? Be effective at the place that you already have a problem, the edges. You can run the machine down an edge while it's spinning, perfectly balanced. That's the trick to get really good at paint correction. Balance, free spinning, right? So same thing here. I do my edges, coincidentally this gets done. Same thing here. I walk around this edge with the machine, I get this, you know, and that really only leaves me like kind of this area at the very end. I may make 2 passes in there, then I'm done. After I do my edge work. So I do this edge, this edge, this edge, this edge. I may still have 1, 2 sections left to do in the middle of the door, and I'm not left with any crappy scratches around the edges at the end, which is what I'm usually fighting against anyway. So, I think most of the rest of it you will get through hands-on, but just remember, keep the machine free spinning. Find a way to make it as flat as possible. Every panel of that car is curved, so you're, you know, maybe 3% of the time you can actually have the full machine completely flat. Other than that, you're always finding a teeter-totter, perfect balance. There's a way to hold it and manipulate it to where it's like, there's the money spot, start spinning, I got my spot, I walk that line. If I get halfway down my line and I'm watching these black lines on the back of the machine that this doesn't have, so this machine, these black lines, whenever you're in free spin, they look, you can tell. Whenever it stops spinning and only shakes, then you have that line and it just goes in one spot. So that's your visual cue to be like, I'm off. Stop, find your spot, spinning again. Now I keep on traveling down the road. If it's just oscillating, does it remove clear coat? Yes, it does. But it's also doing 2 things. It's performing less effective than if it was spinning. And what causes micromarring? The oscillation. So I'm putting much more oscillation in a focused area, which is going to more aggressively mar the surface, which causes a problem that I have to solve in my finishing step. So just to be aware of that. Yeah. I was just thinking of something else. Yeah, keeping the machine flat. I think that's all I got. So really, what I want to do, we want to work on this car. I'll show you a section or 2, and then I want to put a machine in your hands. Your goal is to pick your section and get it perfect, right? Like me, Rob, we're here to help you. We're here, and really, you know, like I want, whenever you first pick up the machine, your very first objective is to go, this thing's jacked, right? So we're going to go from jacked to perfect. Once you complete that task, if you want to put the machine down, you can. If you want to run it for the rest of the day, you can. But you're going to show me that you can take it from jacked to perfect, because it's a process. You all can do it. It's easy. We just go through the steps. We use our tools. We measure the level of aggression, and then we execute the process, right? So after I finish my paint correction, and I'll tell you how I do it too, is I usually tape the car, give me 1 second. Tape the car off, that way I'm protected. I compound. Compound is more likely to stain. The 1500 won't stain, the finesse won't stain. That's Americana stuff. Benzerna, I think will, finesse won't. So when I'm compounding, I'm covered with tape. After I finish compounding, because I complete that process as a whole, I usually pull my tape, because at that tape line, you usually have like that white compound that gets stuck. So if I pull that off before I polish, then when I polish, I knock that crap off, and I don't have to worry about cleaning it right before I start my coating. Compound is powdery, makes more of a mess. So work really clean. Don't let dust build up on the car. Don't let the car get completely covered in dust. Use your air hose that you're using for the pad, blow the dust off the car. the dust is on the car, then dirt dust comes to rest in my compound dust. Then I take my towel and I wipe it in and I reintroduce some nice scratches that I have to get back out. It's annoying as hell. So by working really clean, you are preventing causing yourself a problem, right? Polishing is very clean, it doesn't make a mess, so I usually pull all the tape, wipe out the door jambs, polish, and then it may take me 10 minutes to prep for coating at that point because I've utilized each step to prepare me in the best way for the next step. So, compound, pull your tape, you don't have to, that's how I do it. Wipe out the door jambs, polish the car, and then we're gonna do 2 wipes. First one is wax and grease remover. Solvent-based wax and grease remover on paintwork. That means go to your auto body supply shop, the paint store, go to AutoZone. But you have to have a solvent-based wax and grease remover. IPA, alcohol, and water is not strong enough. Stripper, it may be strong enough if you do it like 3 or 4 times for like Menzerna. Menzerna is a very high oil compound. So it's leaving behind oils, wax, polymers, sealants. There's actually like solids of aluminum in compounds. So there's some really aggressive solids, which are abrasive, to break down the clear coat. You gotta get all that shit off, right? So wax and grease remover is going to strip and exfoliate those out. Then I'm gonna do 1 final wipe with alcohol and water, which is essentially just cleaning up everything that I just solvent stripped out with my wax and grease remover. Final wipe, 50% IPA and water. Bottled water, 90% IPA. Do your final wipe, now you're ready to coat. Any questions? Oh yeah.
You never went over why they're different colored pads.
The color doesn't matter from one brand to another, but if you're executing with one brand, color establishes, is it a cutting pad, is it a polishing pad? You can tell by the density of the foam. So, most aggressive, feel it, middle of the road, least aggressive. They're very, the structure, integrity, the body, the chemistry of it is very different. You can feel it.
So you're
Color
talking
does not identify.
Kind of compound with the white pad?
So, yes.
Okay.
So I got a deep scratch. How do I get a scratch out? Through abrasion. If I'm trying to get a deep scratch out, if I use a less aggressive tool, can I still get that scratch out?
You might have to work at it a little bit longer, but you're going to find out.
Exactly.
Least aggressive, where you need to go a little more aggressive, a little less aggressive,
Right.
whether it's going to move your
So you can
stretch.
compound with the black pad if you want to spend twice as much time
That's
compounding. It's up to you.
Okay.
It's a less effective tool, right? So we're already assessing the tool, the process, and then we're executing. You can combine, like on that scale, all these have a 0 and a 10. I can pick a 3, a 4, a 6, a 7, and it's going to put me at a point on a scale. So I can manipulate the speed of the machine, the pressure of the machine, my tempo, the aggression of the liquid, the aggression of the pad, the size of the section. I can manipulate any one of those things in a more aggressive or less aggressive way, and I can get to the middle ground by manipulating something no matter what, right? So we're just trying to find a way to get from 0 or from 10 to 0 as fast as possible. So,
That's why a lot of times when I with the pads and the colors, I'm always feeling. I feel it, and especially like when I'm compounding, and I want to go like, because typically in most of the orange ones are mostly the cutting pads, but you can have some that are a little bit light, a little bit less. But what I'm doing is when I'm cutting or when I'm working on something, and I want to step it up a little bit, I'll either, and I have like, say I have my same product, then I'll feel my pad, and I'll say, okay, this one is going to get me up just a little notch, rip it off, boom, put that on, or if I want to go less, just buy
ideally, you would want to know what it is without feeling it, right? You want to have to sit there and feel all these different paths.
Right.
And to further communicate that point, if you want like 400 and finesse, I can get any car perfect. 1500 and finesse, I can get any car perfect. 1500 and Sonax perfect finish, I can get any car perfect. The process is how you get the car perfect. The product is just a tool. It can be
Right.
less effective or
Right.
more effective. Doesn't really matter. I don't talk a lot about these brands, although I do endorse and support brands, but the process is what's important, the technique. What are the variables? How do you control the variables? What is each one of these tools doing for you, and how can you manipulate its performance by adjusting your technique? So, Rob, you want to do a couple test sections quick?
Yeah, I actually did a couple, and then I'll kind of show you technique real quick, but y'all want to come check this out.
So let's kind of move our chairs out of the workspace here. So if you were starting and finishing a car, every time you move from one step to the other, you want to be set up for success. That means you want to have all your power washer, all your cleaning chemicals, your brushes, your towels, everything ready, your clay, your iron fallout remover. You got to have all that stuff right here on my desk before I start cleaning the car. Because every time I have to stop and go get something, that takes more time, it decreases my production, and it messes up my cash flow. So you got to think about things that are going to increase your cash flow. Being more efficient, being more effective, having all your tools, spending less time on the job is all going to increase your production and make you more money. That's going to have everything ready to go. Set up your area. Don't make a mess. Like I said, work clean. So if the customer walks into your shop, don't want them to think you're effing slob by the shit mess you got going on while you're doing this car. You walk in here, this is a clean environment. If you're a client, you walk in here and you're like, this person respects my car, their business, and themselves. Just by looking around, I can tell that.
And they'll say it. Damn, I'm in the right place.
Have a system. See all this? Windows dirty, windows clean. They're all different colors. They all have labels. They all get washed together. That way you can manage your towels. Towels is one of the largest expenses